So the flipped classroom for me, I agree with probably every single definition you're going to say. It's about doing the theoretical at home and coming in for the practical. It's about watching videos instead of listening to lectures. It's really all of those things. It's also about a kid playing with Lego. And I think there's some really interesting applications of the approaches of teaching that are very relevant to STEM that apply across the board. And what I think is really interesting about the way STEM is typically taught is that there are two aspects. And one of the things that really separates the way you teach STEM from other areas is that there is the theoretical aspect, lectures, homework, assignments, tests. But there is a practical aspect in almost all fields of study at almost all levels of STEM education, which is traditionally called the lab. The lab-based learning is unique in that it is, really by definition, hands-on. And I think that hands-on piece is a big part of what I define as the flipped classroom. Whether it's conversation or whether it's building something, it is about doing it yourself. It is about having those learning moments based on your own investigation. One of the most important things that engineers need to learn in school is not about the material properties of that or how to build this. It's about a process. And I think that's true a lot of the time, regardless of what the educational setting is. You can teach people details, but if they understand processes and reasons, then it always sticks a little bit better. And for engineering, it is an iterative process that they need to learn. They need to learn, I'm going to make a hypothesis about what's going to happen. I'm going to design something, and then I'm going to test it, and I'm going to observe what happens, and then I'm going to refine my hypothesis. And through that whole process, what I'm going to really do is learn and build an intuition. And it is a continuous process, and built in within it is a need for documentation, and the end result of it is oftentimes certification. We all know we learn best when we screw up. Those are the lessons that really stick. And it's my feeling that in a lot of education, or a lot of training, the learner, forget education, in a lot of training, the learner is not given an opportunity to fail. They're often not even given an opportunity to try. And I'll get to that a little bit later. So the connection to corporate training. There's a need for application beyond just experience, or beyond just the learning experience. Also, the term differentiated instruction, I know everyone has heard that. This idea that certainly in the K-12 settings, we have kids that learn at different rates and different ways. We have to be very sensitive to that, and great teachers are very sensitive to that, and that's where the hands-on piece really makes sense. So there really is a need for that. And even beyond the need for what are K-12 students and as they turn into college and university students, there's much greater differentiation between the individuals in the workforce for corporate training. Huge range in age, huge range in experience, people who are training for their third careers versus the young whippersnapper who just got hired. There's a huge spectrum of what they need to get out of it, right? Someone who may have never held a screwdriver before is going to have different needs than that senior toolmaker out of the health and safety training that they all take at the same time, okay? And also, there's a really considerable need for scalability. Scalability is our biggest challenge. Why else would we convert from classroom-based training to web or online training? There's a lot of people saying it's about scalability. I actually argue that there's more that you can get out of it than just that scalability piece.